So today we are going to see something about 3D transformation. Earlier we have seen our two-dimensional transformation. In transformation we have several operations like translation, rotation, scaling. We have also seen reflection and searing, right? So we have to understand here how this kind of transformations can be performed in 3 dimensions. Let us start with understanding how a point may be represented in a 3 dimension. The 3 dimension means x and y, which we have been encountering in our 2 dimensional studies. Now since it is 3 dimensional study, so we have x, y and z axis. So each point will have 3 coordinate values in terms of x, y and z coordinate. Now when we are thinking about transformation operations, the first operation which comes is translation. I believe you will remember in translation what was happening, you were moving your point from one position to another position. Suppose this point has a position x, y and z, and you want to move it to a new position x dash, y dash and z dash. In that case you need to perform an operation, we call it translation, and we have a translation here we are calling it vector, means I should say a factor. A factor is usually when it is multiplied, so it should not be called as factor. But one thing is clear, that it is a certain value which will be added to corresponding x, y and z. So the new x dash here, it will be original x plus tx. Similarly, the y dash here will be original y plus ty, and this z dash will be original z plus tz. Okay, so these tx, ty, tz are some values which will be added to this x, y and z respectively to get our new position of the point. Okay, so in terms of matrix operations also it can be represented as the new p dash is equal to t into p. So the new p dash, if at all you are representing it as x dash, y dash and z dash. Let me also include the homogeneous coordinate here. Okay, so then how can you represent it with a homogeneous coordinate multiplication? Earlier in last case, in 2-dimensional translation, what was happening, you were having x, y and 1. Now you will have x, y, z and 1. So here also the matrix will be 4 cross 4. As earlier it was 3 cross 3, now you will have 4 cross 4. I remember here it will be a 1, right? Since it is a translation, so what is how do we write a translation matrix? Anybody, can you remember anything? How do we write a translation matrix? What should be the value here? We are expecting in x dash, we expect as x plus tx, y dash we expect y plus ty, in z dash we expect z plus tz, and 1 will remain 1. Okay. So can you tell me what should be the matrix so that we could get this result?
So for the last column, it will be Tx, Ty, Tz, and then 1, and all remaining elements are 0,
These diagonal values
are 1.
okay. Yeah, so this is our thing for translation matrix. If we want to perform this translation, this is how we do. Okay, we have just to keep these values tx, ty and tz in the last column, and then we can perform the translation operation. So addition of some values, it will move these the position, I should say the point, in a particular direction to some point. Now if you want to bring it back, you can definitely use the negative value of these tx, ty and tz. Okay, then the position will come back to the original place. Now this was only for a point. Now suppose you have an object and you want to shift it to a new position. Do you think it is possible? Can you shift the whole object from one location to other? You have to answer. Do you think it
Yes,
is
sir.
possible?
Yes, sir.
How can we do that?
Sir, we will perform this translation on each pixel of the object.
Yes. So each point of that object we will perform this operation. All the pixels, all the points will be transformed to a new position. Okay. In that way the whole object will be translated. The next thing is rotation. Rotation we have already seen in our 2-dimension studies, but here it is different from 2-dimensional studies. It is a 3-dimensional rotation. Okay. Now it can be actually done in corresponding to any line of sight. Okay. Whenever you were doing in 2-dimensional, it was only xy plane, right? So considering z line, you can rotate between x and y. Now if you consider the x axis, you can rotate between y and z. If you consider y axis, then you can rotate from z to x. Now important thing here to understand is positive values of the angle and the negative values of the angle. Okay, if your theta value is positive, then what will happen? In xy plane you can easily understand, if it is positive, so what is happening? It is going upwards, right? Let me say it is going counterclockwise. Counterclockwise. Okay, and if at all the theta would have been negative, in that case it will go clockwise. So having this understanding, it will be clear that if at all you are keeping z, then only on x and y it is going in this direction, it is counterclockwise. For positive values, for positive value on such a rotation where you are keeping around x axis, okay, around, not, it should be called as along x axis. In that case, y to z. If you are keeping y, then the angle will be z to x. Okay. Okay. Now having understood this thing, let us start with this example where we are performing rotation along about the z axis. Not along, let me call it about. So about z axis, what is happening? Whatever the object was there, z axis was there, and keeping this z axis in mind, the object is rotated from x to y. Okay. Now what we have to see here in rotation of 3D objects is the three ways of rotation. Okay. Earlier in 2D rotation we had just one formula for the rotation, or I should say one equation, or I should say one matrix for rotation. However, now we will have three different matrices. One matrix for rotation about z axis, one matrix for rotation about x axis, and one matrix for rotation about y axis. So let us first discuss about this thing, the rotation about z axis. Here you can easily understand, for a pixel here, if it is rotated with certain angle theta, in that case what will be the new position x dash and y dash? Definitely z dash is the same thing, z is not changing. Okay, means how far it is from xy plane, it is not changing, it is remaining in the same distance from xy plane. Okay, so z dash is z only, no problem. Only the values of x dash and y dash is changing. So all the x dash will be the same thing as it was happening, x cos theta minus y sin theta, and y dash will be x sin theta plus y cos theta. So after seeing this, can you tell me what will be the matrix representation if you want to have x dash, y dash and z dash, and suppose 1, then you will need to multiply two matrices. One is this matrix, which will be multiplied by x, y, z and 1. Now you have to tell me what will be this matrix. I believe everybody will agree it will be 1, and these will be 0, 0 and 0. Here also it will be 0, 0 and 0. Now can you tell me what will be the other values?
Sir, first row will be cos theta minus sin theta.
Cos theta minus sin theta, and here
0.
0. Is it correct?
And yes, I think. Yeah, because for x's we don't have any factor with z. It is x cos theta minus y sin theta.
Okay.
And second will be sin theta, cos theta and 0.
Sin theta plus cos theta plus 0. And then
0, 0, 1.
0, 0 and 1. Okay. Definitely it is correct, because it will give us this desired solution, cos theta minus sin theta x and y, and here we don't have anything z, so it is 0. It's okay. Here x sin theta y cos theta, it is also okay. Here we only want z as it is 1. Okay. So using this kind of thing, using this rotation, what is happening? Your object, the z axis is constant, the object will be rotated from x towards y. Okay. Similarly, there can be other rotation operations where you want to perform rotation about x axis, it is possible. Rotation about y axis, it is possible. So let us suppose it is rotation about x axis. Then what will happen? So this will be rotation about x-axis. This was your y-axis. Now the x-axis is constant. The object, wherever it was, whatever the x values were there, it will remain as it is. Only the y and z values will change. So this value will, this object may look something like this. Okay. So for this again you have to understand what will be the matrix x dash, y dash, z dash and 1 is equal to your matrix into x, y, z and 1. This matrix here x has to remain constant. Okay. Homogeneous coordinate always remains constant. So I am keeping 0, 0, 0, 1 and here also 0, 0, 0, 1. Now you tell me what will be the other values. First row.
1 0 0.
1 0 0. Why do you think so?
So because x is constant, so x dash is equal to x.
Yes. And y dash, what should be the y dash value?
Sir, so it should be like y cos theta minus z sin theta.
Yeah, it is correct. So how do you know this will be this thing? Were you able to understand, or you are guessing, or you have already studied this?
No sir, what I did was in previous case we had rotation about z axis. So there we kept z constant. So I just replaced z with x and y, and this y with y with x and x with y.
So I am confused. Y dash you are saying this, then z dash will be something like y sin theta plus, is it z cos theta?
Yes sir.
Okay. So what do you think this is correct? Why not y dash is equal to this thing y sin theta plus z cos theta? Why not up and down this thing? Whatever it is written here, it is correct. My question is, why do you think this is correct? Why not the opposite? If I write the opposite, is it wrong? So whenever we are writing this rotation, we are considering the positive rotation, I should say the counterclockwise. Okay, so when we are thinking that z is constant, we were taking like something is going from x to y. Okay, so in that case, we were trying to find x as something cos theta or whatever y x cos theta minus y sin theta. So similarly here what we are doing, we are keeping x constant and we are rotating from y towards z. So now this is our y and the other is z. So here y will be treated as x and z will be treated as y in our earlier rotation equation. That's why y dash will be this y cos theta and z sin theta only. How we have arrived to this formula, I believe we have already talked about it in while talking about rotation, 2D rotation, that this is the formula. So one thing that we are considering is it is a positive rotation, so it is going counterclockwise. So now it is going from y to z. So for y, this is the equation, which is y is with cos theta and minus z sin theta. So here I believe it will be 0 cos theta minus sin theta. Am I writing correct?
Yes, sir.
0 sin theta and cos theta. So in this way, what will happen? X will remain constant. However, this rotation will be about x axis, so y and z values will definitely change. Now the other thing. The next thing will be rotation about y axis, right? So if rotation will be about y axis, in that case what will happen? In this case what happens? Y is constant, the object is moving from z towards x. Okay, in this kind of rotation is going on. So here also you will have similar kind of matrix operation where you will have your x dash, y dash, z dash and 1, which will be the result of multiplication of two matrices. One is definitely your x, y, z and 1 is your rotation matrix. Here I know that this homogeneous coordinate will be 0, 0, 0, 0, 0, 0. Okay, and then here definitely we will have something. Y is constant, so that means I believe this row is for constant. Y comes here, so this is 1 and these places are 0, if I am correct. Then y is constant, it is moving from z to x. In that case it will be your z dash will be, what this z dash will be?
Y cos theta minus.
No, y is constant. It is moving
X
from z to x.
Okay, sir, z cos theta minus x
Z
sin theta.
cos theta minus x sin theta. Yes, it is correct. And then what will be the value of x? X dash will be
X cos theta plus z sin theta.
Yeah, it
X
is
cos
correct.
theta.
It is correct. So let me write z first. Z sin theta. This is how we write. So that is why we are writing like this. X cos theta. Anna? Is it clear to all? Do I have to say something here? Earlier what was happening? Something was moving from x to y. So first of all we were finding the value of x and then the value of y, isn't it? So value of x was something like x cos theta minus y sin theta, right? Similarly, here in this case the object is moving from z to x. Okay, so in such rotation what will happen? Z is coming first. Here what was happening? It was going from x to y, so x was coming first, y was coming second. Here z is coming first and x is coming second. So it will be something like this: z cos theta minus x sin theta, z sin theta plus x cos theta. Now we have to put this here. How should we put it here? Z dash, this one will be z cos theta minus x sin theta. Okay, so this is what will be multiplied by x, this is what will be multiplied by y, this is what will be multiplied by z. What do we want? We want to multiply cos theta with z. We want to minus sine theta to x. Nothing is given for y, so it is 0. Is it understandable? Similarly, for x dash here, for x dash you want to multiply z sine theta. So there is something that you will multiply to z, it is sine theta, and then there is something x cos theta. You will multiply something to x, which is cos theta, then 0. So this will give you the rotation about y-axis. Was it easy to understand? I believe it should be easy to understand. It is nowhere different from that two-dimensional rotation that we have studied, where we had just x and y. Now we have three dimensions, so there are three possible rotations. Rotation along x-axis, about x-axis, about y-axis, about z-axis. So about z-axis is the same thing that we had been doing with our x and y-axis, right? So after that we have seen about x-axis what was happening. It was object was moving from y towards z. Now here we are saying something rotation about y-axis. In that case, the object is moving from z to x. In that case, the y coordinate values are as it is. Only the changes are in z and x coordinate values. So this is how rotation is done in three-dimensional coordinate system. Now one important thing comes here in our mind is the general rotation that we had been doing with our two-dimension also. That this rotation that we are going to do, whether the object is somehow coming towards parallel to some of the axis or not. Okay, if at all it is not coming parallel to some of the axis, in that case there may be some problem. Okay. Is there something? Anybody want to ask something? This is our general 3D rotation, and here we are thinking about rotating an object about any axis. In that case, we will translate the object, bring that object at a place where the rotation axis, suppose this was your object, then rotation axis may be on a middle, okay, so, or center I should say. So that rotation axis coincides with any parallel coordinate axis, okay. Or after coming on the coordinate axis, you can easily perform the rotation. You perform the rotation in second step, and then in the third step, what you will do, you will retranslate it. Translate it back. Okay. So in that case, now when it will be translated it back to the position, there it will go in a rotated form. So there a rotation will be performed. So here what you can think is, you can perform the rotation as well as translation with on your pixels or your positions, I should say. So this thing you can definitely write in a composite matrix. What will you have in a composite matrix? Composite matrix, you will have your translation followed by your let me write it like this. On the right hand side, this is the first thing which will perform translation, then rotation, then inverse translation. The rotation will always be with some angle and by some axis, about some axis. So suppose it is about x axis. So such kind of thing can be your composite matrix. Okay, this is, let me write, it is a composite matrix. So this matrix you can multiply easily with each. After multiplication of this, you will get a composite matrix, single one, which can be multiplied directly to the particular this thing pixels, so that you will get your desired result. However, this was the case when you wanted to rotate about any axis. What if you want to rotate about the origin, right? Okay, means some kind of rotation is being done. So means okay, I am not able to tell you what I am saying, right? What I am saying is, this particular object, when it was parallel to a particular axis, then you were easily doing something like this. If at all it was not parallel to any axis, okay, what can be that particular case? Okay, something is here which was already perpendicular to parallel to this particular axis. This particular thing was rotation was to be done, so it was parallel to this thing. However, now it is different. Okay, you want to perform the rotation, but it is not parallel to any axis. In that case, what you will do is, you will first of all bring it to the origin. Okay, first of all bring it to the origin, then rotate the object itself to bring parallel to any one of the axis, then perform your desired rotation. Okay, then the reverse thing, perform your normal rotation, whatever rotation you had done, back it, and then retranslate it to the original position. Okay, simple thing. What we are earlier there were 3 steps, now there will be 5 steps, right? 1 and 2, 3, 4, 5. The first step will be translation. Okay, bring the object to the origin, translation to origin, then rotate to make it parallel to any axis, any desired axis actually. Okay, then perform the rotation, and after that inverse rotation, and then inverse translation. So this is something that can be done with our rotation. Okay, so we have seen some of the things in our rotation. Is there something that you want to ask in rotation? And after that, the next thing that we have to see will be your scaling. I believe scaling will not be that big thing. I believe we can complete it today itself. Before moving further, let me ask if you have any confusion, you want to ask something.